All right. Good afternoon, ladies and gentlemen. Good evening. Welcome to another series of tutorials with me, Aubrey. This is going to be a very interesting lesson because I have something for Mufurila College of Education. This is from the complex analysis section, or also known as a theory of a complex variable. This is a tutorial sheet, Mat 410. So for more videos such as this, subscribe to the channel and leave the like. Is it leave or like the video for it to be suggested to other people? All right, so subscribe and leave a like. All right, so let's dive into the lesson. So basically what I'm going to be doing here is just giving you some ideas on how you are supposed to go about the questions, and from there you will be able to do it by yourself. So let's start with question one. Question one, we have some equations here. Excuse me. So we have some equations here. Let me just zoom in on the question so that you are able to see props. All right, so we have some questions here. Solve the equation z to the power 4 minus 16 equals to 0. So now what you do is, before you start solving an equation, you need to have a mental idea of what the equation is about. Okay, so when you have one variable in the equation like this, we have only one variable. There is no different variables. Like here we have two variables of z. We have z to the power 4 and z or 2, and we know that these are of two different powers. So if we have one variable, okay, or maybe we have several variables of the same power, we need to add those variables of the same power. Then we see that we're going to have one variable. So in a case where we have one variable like this one, what we need to do is, or let me say, what they are asking us to find is just the nth root. So we should write this in the form z to the power n is equals to x plus iy. Okay, so in this case, this is z to the power 4 being equal to positive 16, and our x in this case is 16 and our y is 0, as you can see there. So basically, if you have such an equation, all right, we know the formula that we are supposed to use. The formula we use is whenever you have z to the power n, this is equals to the nth root of the radius, open brackets, cos theta plus 2 pi k over n, close parenthesis, plus I sine the same thing, sine theta plus 2 pi k, sine theta plus 2 pi k, all over n. We close and we close right there. And from here you have everything that you need. Your n in this case is the power. Okay, our n in this case now, and our n in this case will be just 4 there. So our n in this case is equals to 4. So we say n is equals to 4. Then our theta, to find our theta, we say this theta is equals to tan inverse of the imaginary part over the real part. And of course, the imaginary part in this case, we see that this is plus I0. So I times 0 just gave us 0. That's why we just remain with 16 like that. So we see that the real part is equals to 16. And the imaginary part is equals to 0 in this case. So we just replace there. Then we find our r. Our r is equals to the root of the real part squared plus the imaginary part squared. All right, then what else? We also need to find the values of k. So how basically we're going to be doing is we are going to be arranging from k is equals to 0, from k is equals to 0, 1, and the last number should be n minus 1. So what we're going to be doing, if k is 0, what is the value of this that is right here. So we'll be replacing here. If k is 0, so theta, it will be a constant theta there. If k is 0, this will be 0, n will be constant there, and so on. I'm sure you have an idea from the complex numbers in second year. So this is from 0 to 1, 2, and the last number is n minus 1. So n in this case is 4. 4 minus 1, that is 3. So these are the values of k we're going to be testing for k equals to 0, for k equals to 1, k equals to 2, for k equals to 3. And that is question 1. We are done with question 1. So that is basically how you approach question 1. So let's look at how we can approach question 2. Let me just clear this out. Okay, I'll just cut it. Okay. Question 2. This is also an equation. And as you can see here, we have z to the power 4 and we have z squared here as the only term. So in my vision, this z to the power 4 can be written as z to the power 2 to the power 2, all right? Then minus 4 z squared plus 4 minus 2i being equal to 0. All right, so so this is almost done here. So we just let z squared to be any letter of your choice. I'll choose A because my name starts with A. So here we're going to have, where there is Z, we're simply replacing with A. So here we're going to replace A, and here we're going to replace A. So we're going to have A squared, okay, minus 4A minus 4A plus 4 minus 2I, that equals to 0. So you notice that I've put that in parentheses because what we have here is a quadratic equation from which our coefficient here is 1. The coefficient of A here is 1. So this is our A. Our B is 4. And this is our C. So now we are just going to replace that in our quadratic formula. Remember your quadratic formula. Just clear this. Remember your quadratic formula. In this case, we are finding capital letter A. So we're going to say capital letter A is equals to negative B plus or minus root of B squared minus 4AC all over 2A. Then our A will be equals to, what is our B? So let's check here. Our B is negative 4. Negative 4, our C, our A is 1, and that is so. So our B is negative 4. So negative times negative, it will be positive 4 plus or minus root of B squared, which is 4 squared, negative 4 squared. Okay, let me write that negative 4 squared minus 4 times A, which is 1, times C, which is 4 minus 2I. Closes the brackets, all over 2 times A, which is 2 times 1, meaning that our A will be equal to, so let's simplify, this is our 4 plus or minus root of, this would be 16, negative 4 times that would be negative 1, negative 4, so it would be negative 16 plus 8i all over 2. All right, so now this then becomes our A being equal to 4 plus or minus root of 8i all over 2. So that is our A. So we can further simplify this as A being equal to 4 plus or minus 2 root of, is it like that? 2 root of 2, is it? So this is 2 root of 2i all over 2. Yes, all over 2. Then All right, then from here we can simplify our a as being equal to 2 plus or minus root of 2i inside the brackets. The I is inside the brackets. So now this is our a, but we said we had let but z squared is equals to a, so we replace back. Therefore we are going to have z squared will be equals to 2 plus or minus root of 2i, of which z will be equal to plus or minus root of 2 plus or minus root of 2i. Quite an interesting answer there. So this will be your z there, and as you can see we have four answers there. So that is your z. So that is how you find your z, and that is your question 2. I promised to not to solve the entire question, but I got tempted. So, but that is how you're supposed to approach question 2. So let me go to question number 2. Number 2, let me just clear out there. Number 2, question 2. All right, find the maximum value of z to the power 4 plus z if z modulus is less than or equal to 1. So this is where our emphasis is. Z modulus is less than or equal to 1. Now the question I'm going to ask you is, what value of Z modulus is greater when we look at this? What is the maximum of this inequality? Okay, so the maximum is when Z is equal to 1. So that is the maximum of this inequality, because they are saying Z modulus can only be equal to or less than. So less than will be the minimum and equal to will be the maximum. So that is where we are going to use. So we're going to use this. Then we have Z to the power 4 plus 7. We are finding the maximum value of this if Z modulus is equal to 1 in this case now, since that is the maximum value now. So now we are going to use the triangular inequality and say this is equal to, this is less than or equal to Z to the power 4 plus Z modulus. So you say by the triangular inequality, I'll just say by triangular inequality. You need to finish this one though. So that is by the triangular inequality, that is equals to that. And we know that when you have a to the power n, this is equals to modulus of a, then the n can go there outside. So you're going to say this will now be z to the power 4 plus z plus 7, sorry, is less than or equal to z to the power 4 outside there plus 7. Then say, but the maximum of this, so we're going to say but z modulus is equal to 1 for the maximum. So if z modulus is equals to 1 for the maximum, then we are going to have z to the power 4 plus 7 being less than or equal to, where there is z modulus here, we can put 1 to the power 4 plus 7 modulus, like that, meaning that this to the power 4 plus 7 can only be less than or equal to 1 to the power 4 plus 7, that will be 8. So the maximum value of that is 8 here. So meaning that the maximum of 7 to the power 4 plus 7 is 8. According to this, it means this is equal to 8 or less than 8. So that is basically how you approach this question. So if you're liking this video thus far, you can like the video, subscribe. Yeah, so let's look at the second example.